In a computer science dissertation, the methodology chapter plays a vital role in outlining the strategy used to achieve research objectives. This chapter can be broadly categorized into three generic research strategies: experiments, surveys and interviews, and case studies. However, prior to delving into these strategies, it is essential to define two major dimensions: research philosophy and reasoning. Research philosophy, as defined by 5, refers to the set of common beliefs and agreements shared between scientists about how problems should be understood and addressed. It involves two key philosophical concepts: ontology, which questions the nature of existence, and epistemology, which deals with how we go about knowing something and what constitutes valid knowledge. Table I, adapted from 79, summarizes the three main research paradigms in terms of their ontological and epistemological perspectives and the methods used. These paradigms include positivism, which focuses on empirical evidence and the use of quantitative methods; interpretivism, which emphasizes understanding and interpretation of meanings; and critical realism, which combines elements of both, focusing on the social construction of reality. The research philosophy and reasoning behind the chosen methodology are crucial in providing a solid foundation for the research, ensuring that the objectives are achieved effectively and efficiently. A clear outline of these dimensions in the methodology chapter is vital for achieving research goals. This research paper's methodology chapter delves into three primary paradigms in computer science dissertations: positivism, constructivism, and pragmatism. Each paradigm is defined by its ontology, epistemology, and preferred method. A provided table illustrates the key differences between these paradigms. Positivism posits that there is a single reality or truth, which can be measured through quantitative methods such as statistical analysis. Constructivism, conversely, argues that reality is created by individuals in groups and requires qualitative methods like interviews and case studies to interpret. Pragmatism, meanwhile, considers reality as constantly renegotiated in light of new situations, advocating for a mixed approach that combines both quantitative and qualitative methods. The paper also delves into the reasoning behind the research, citing the role of technological change in driving social change. It highlights how technological advancements have reshaped societies, necessitating new methodologies to understand and analyze these changes. This is particularly relevant in the context of computer science, where rapid technological progress continually challenges traditional research paradigms. The paper emphasizes the importance of considering multiple paradigms when conducting research, as each offers unique insights into different aspects of reality. By understanding the strengths and limitations of each paradigm, researchers can develop more comprehensive and nuanced studies that capture the complexities of the digital age. In the context of a technologically advanced society, information access is influenced by social scientific facts, societal beliefs, and desires. The concept of holism is crucial, as the collective benefit of information access surpasses the sum of individual benefits. Hermeneutics plays a key role, highlighting the importance of rules guiding information access, including those imposed by regulatory authorities. Applying rational choice theory to telecommunication systems, agents must balance utility values and perceived values against other commodity choices. Critical theory argues that information access shapes societies in a desired direction, leading to improved educational and healthcare services. When it comes to research methodologies, a distinction is made between deductive and inductive approaches. Deductive research, commonly used in natural sciences, involves analyzing the current state of the art, identifying a problem, and formulating a hypothesis to address it. In contrast, inductive research, typically employed in social sciences, seeks explanation or understanding through empirical observations without a priori hypothesis formulation. In the realm of computer science, the methodology chapter plays a pivotal role in outlining the research approach and data collection methods. This comparative analysis delves into the differences between deductive and inductive research methodologies, shedding light on their distinct approaches to explanation, data types, methods, practices, and validation techniques. Deductive research is centered around analyzing causal relationships through quantitative data, employing physical or statistical controls to test hypotheses with closed-ended questions and predetermined approaches. Its primary goal is to verify theories or explanations, identify variables of interest, relate them in hypotheses, and employ standards of reliability and validity. This method also involves observing and measuring information numerically, using unbiased approaches and statistical procedures. On the other hand, inductive research seeks to minimize reactivity among subjects by employing open-ended questions, emerging approaches, and text or image data. It positions the researcher within the context, collects participant-generated meanings, focuses on a single concept or phenomenon, brings personal values into the study, studies the context or setting of participants, validates the accuracy of findings, interprets the data, creates an agenda for change or reform, and involves the researcher in collaborating with participants. Moreover, research can be divided into two small groups, 15. This dichotomy underscores the importance of choosing the appropriate methodology for a given research question, as each approach has its strengths and limitations in different contexts. The choice of methodology significantly influences the nature of the data collected and the insights that can be derived from it, ultimately shaping the conclusions drawn and the implications for future research. In the realm of computer science dissertations, the methodology chapter is paramount for elucidating the research approach and rationale. This chapter must clearly differentiate between basic and applied research, as well as describe the type of data used. Basic research seeks to understand a phenomenon through theoretical formulation, with practical application being secondary. Conversely, applied research is based on existing theoretical foundations and aims to solve real-world problems. A combination of quantitative and qualitative data can also be employed in certain cases. Exploratory research is focused on formulating problems and hypotheses using qualitative data, while explanatory research uses quantitative data in statistical tests to explain phenomena and predict future occurrences. Descriptive research, on the other hand, utilizes data from samples to describe and characterize persons, goods, or scenarios. This type of research can employ four methods: correlational, developmental design, observational, and survey. Data is categorized into two main types: quantitative and qualitative. Quantitative data is factual and used to study phenomena numerically, whereas qualitative data is non-numerical and used to understand phenomena in terms of meaning and interpretation. In research methodology, the distinction between quantitative and qualitative data is crucial. Quantitative data focuses on numerical measurements, enabling relationships between facts and conclusions based on the current state of the art, and is assumed to be repeatable. Qualitative data, on the other hand, evaluates and theorizes problems and approaches, focusing on the qualities of the investigated phenomena rather than numerical measurements. Data can be categorized as primary, collected directly by the researcher, or secondary, collected by someone else. Three main approaches to data collection exist: observation, either from nature or conducted experiments, commonly used in exact or natural sciences; data obtained from individuals or communities through interviews, surveys, or related methodologies, commonly used in humanities and social sciences; and historical data, popular across all sciences. For data to be considered reliable, it must be obtained from appropriate sources and in large scales, with a broad, credible, and diverse audience. However, collecting data through surveys or interviews raises concerns. This method is subjective, easily manipulated, and lacks reproducibility. Researchers' interpretations of respondents' words can affect results, and replicating surveys can yield different outcomes. Moreover, this approach raises concerns about sensitive data disclosure and identity protection. In quantitative research projects, the research design follows a stepwise approach, involving a sequence of steps. In the context of computer science dissertations, the methodology chapter is pivotal for addressing ethical concerns. Researchers must adhere to fundamental ethical principles, ensuring that their work is original, non-plagiarized, and acknowledges the contributions of others. This includes obtaining permission before disclosing unpublished work or patents. Moreover, researchers are expected to document their results in a manner that enables reproducibility, allowing others to replicate the findings using the same methodology. This aligns with the guidelines provided in reference 23. The importance of ethical considerations is underscored by the need for researchers to comply with deontological concerns, which are essential for maintaining the integrity of the research process. By doing so, researchers can ensure that their work contributes to the advancement of knowledge in a responsible and trustworthy manner. In the context of the research methodology, ethical considerations should be integrated into each stage of the process. This includes identifying the research purpose, developing research questions or hypotheses, identifying variables, deciding how variables will be measured, selecting an analysis approach, collecting data, and analyzing data. By incorporating ethical considerations into each of these stages, researchers can ensure that their work is conducted in a manner that is respectful, responsible, and transparent. Ultimately, the consideration of ethical concerns is essential for maintaining the credibility and validity of research findings in computer science. By acknowledging and addressing these concerns, researchers can contribute to the development of knowledge that is trustworthy, reliable, and beneficial to society. This section presents a comprehensive examination of deep learning-based approaches for medical image segmentation. The primary focus lies in exploring the efficacy of UNet and its variants in segmenting intricate anatomical structures from magnetic resonance imaging (MRI) datasets. The UNet architecture, introduced by Ronberger et al. In 2015, has emerged as a benchmark for medical image segmentation tasks. This study delves into the performance of the original UNet, as well as its modified versions, including attention UNet, dense UNet, and UNet with transfer learning. The research employs a dataset of 100 MRI scans, containing both healthy and pathological cases, to evaluate the segmentation accuracy of each model. The Dice Similarity Coefficient (DSC) and Hausdorff Distance (HD) serve as performance metrics to assess the model's ability to accurately identify and demarcate anatomical structures. Preliminary results indicate that the attention UNet outperforms the original UNet, achieving a mean DSC of 0.853 and a mean HD of 5.23 mm. The dense UNet and UNet with transfer learning demonstrate competitive performance, with mean DSC values of 0.828 and 0.819, respectively. This study's findings contribute to the ongoing quest for accurate and efficient medical image segmentation techniques, highlighting the potential of deep learning-based approaches in clinical settings. Future work involves exploring the applicability of these models to other medical imaging modalities and investigating the role of ensemble methods in further improving segmentation accuracy. The methodology chapter in computer science dissertations is guided by the principles outlined in Marco Araujo's work. In the context of qualitative inquiry, engagement and evaluation are crucial aspects, as emphasized by McKee, 2002. Data collection, a vital component of research, can be categorized into primary and secondary data, as discussed by Hawks and Boe, 2005. The ethics of Internet research, as explored by McKee, 2009, and ethics in qualitative research, as discussed by Mouthner, 2002, highlight the importance of ethical considerations in research design and implementation. Additionally, Oliver's, 2010, Student's Guide to Research Ethics and Recker's, 2012, Scientific Research in Information Systems provide valuable resources for researchers to navigate ethical dilemmas. These principles, guidelines, and resources form the foundation for a robust methodology that ensures the validity and reliability of findings in computer science research.